Hiya guys, and welcome back to Wade's Workshop. So this is going to be my first collaboration video, and I brought the green jumper with the holes in out in celebration. So those of you who have been asking where it is, it's back. I've still got it. Anyway, Kris Harbour Natural Building. You've probably seen it in the title, and the link to the channel is in the description. Now, Kris does all sorts of projects. He's built his own house, his own workshop. It's incredible. You know, it's all built using natural materials. What he's got lying about, it's fantastic. He's got off-grid power, off-grid water, composting toilets, log burners, or everything set up in his place in the woods. Probably about an hour away from me, I'd say Kris is based. We've met through a mutual friend. So Raffo, thanks for that, if you're watching. But yeah, Kris has reached out to me to do a bit of turning for him for what he's making a sawmill, basically. And at present he hasn't got a lathe, even though he's more than capable of making these parts himself, but not without a lathe at present. So it's all going to be lathe work. I'll give you a little bit of an overview of what we're going to be making, and we'll jump straight to the lathe. So first part of the project, 2 slugs of steel here. What are they? 70mm diameter by roughly 50mm long. These are going to be turned on all faces and are going to be, if you think of a flanged wheel with a bearing in front and rear, hole through the middle, and some grooves in the flange. And these are guides for the blade. The blade will run up against the flange at the rear and sit on the flat portion, and these will guide the blade. So there's 2 of those to make. And then moving forward, I've got 2 square pieces of steel here and some, if you think of them as large rose joints. These square bars are going to be turned down over a length to suit these rose joints, and these are going to form part of the adjustment to align the aforementioned rollers. So we're going to jump to the lathe with one of these, get set up and get turning. So the first thing we need to do is to put the part up in the chuck. Okay, I've had to use my reverse jaws here because the external jaws on this little 100mm chuck, if I use the external jaws, they're at the point where they're just about to come out of the chuck to hold this 70mm stock. I'm just going to have a quick look, see where we are. Seems to be running fairly true. And the usual first operation is going to be to face this off. Saw cut's not quite straight. So this will bring this face true to the rotation of the lathe. Nearly there, a bit more. So centre drill now, a little bit of cutting oil. With a live centre now. And that's good. So that's held the part in the chuck a lot more securely, and I should be able to rough it out or go a little harder at it now. So my drawing calls for a diameter here, a 51 diameter, back a distance of 25mm. So I just touched off on the front face. I'm very much going to be heating this thing up and getting it hot. So roughing operation, I'm going to take it back 24mm and down to about 52mm diameter. I'm just coming up on a cut now with a power feed. I'm taking 1.5mm off a side. That's 3mm off the diameter in one go. Seems to be behaving alright. Let's turn the feed up a little. Power feed, I'm just taking it gently. As I said, this is a little lathe. But yeah, to take 3mm off that 70mm diameter in one pass isn't bad considering. The final roughing cut should leave me about 1mm up on diameter, about 52mm. Let's just have a quick look. 51.94, no problem. Right, okay, the tolerance on these diameters is going to be like plus or minus half a mil. So anywhere between 50.5 and 51.5. It will be machined afterwards. We will get closer than the 0.5. This part is roughed out now. Length, shoulders, everything's like a mill up. And it's quite hot. We're going to now take the guts out of the bore. Again, a roughing operation. We're going to get a 17mm hole, I think, finished, something around there. Yeah, as long as it's 16.5 to 17.5, 18 would be okay. But a hole right through the middle. I'm just going to start it off. I got a 9mm drill. I'm just going to whack a 9mm drill right through. The 16mm drill seems to like it in there. So I've drilled it right through 16mm. I got a 23mm drill here. It's not going to like it. It's not going to like it at all. But the bearing that's going to fit in it is 12mm thick. So I'm just going to bring this drill to a touch so that the taper touches. Then I'm going to wind in 12 turns just to take a bit more of the meat of the material out. So, right, 12 turns from there. I've got a boring bar up now. We're just taking a couple of flour out of there, screwing it up. We're going to finish it to, yeah, around the 17mm mark. Just boring it out now to 11.5 deep. And again, I'm going to leave it a millimetre undersize on diameter. And that should be it. May have to run that cut through again, we shall see. So I'll just get my snap gauge. I don't quite like the way that feels. There we are. So that's my gauge. In with the micrometer. That's just rubbing there. Is that in shot? I think it is. 1.5 hundredths over 40mm. Perfect. So with a bit of bearing fit, let's just check we've got no errors going on. I'm hoping that just... I can get it started. I'm not going to push it any further than that because I've got to get it out again. But, so as you can see, I'm facing that back face, coming out to my 0 where I machined the diameter. There. I'll just go back in, and I want to machine it. I'm going to machine it to 12.1mm. There's 12. That'll be the shoulder the outer race sits against. We're there. And I'm going to go on my readout 12.1. So that's the finishing pass in the bottom. I'm going to set a 0 there. Come out to the outer edge. Now I'm going to go in a further 0.2 there and come out to within 7mm of the edge. In fact, I'm going to go a bit more. I'll go to 6. There we are. Okay, you can see the little undercut inside, which is going to avoid the inner race. So when the bearing's pushed in, It'll sit hard against the outer shoulder, but the inner shoulder is free and in clearance, because that will be spinning. Okay, so now that we've done that depth to 12.1, I'm going to come to this point here. I did set to 0. I'm going to come to 12, lock my carriage, and just face the front of this. There we go. And that's now my depth set at 12 mil. So we have the diameter correct, we have the undercut for the bearing, and the depth to from the back race to the front race is going to leave it flush with the front. So we need to move on now and finish this outer diameter, which is huge tolerance on this, plus or minus half a mil, back to the shoulder here. I'm just running a scratch pass across the diameter here. Finish looks good, and then I can get a measurement and I know how much to take off. So this should be the final cut on this diameter. It's all cooled down. I'm taking a couple of skims, giving it a measure. The dimension's not critical. I could probably go plus or minus half a mil on the 51, but we'll aim for somewhere near the 51 mark. If it's within 0.1 millimeters, I'll be more than happy. So yeah, finish looks good. I've already faced a bit off the back, so it's about 24.8 now. Just knock that feed off. Take it to 24.8. Just wind out there. And just take that final 0.2 off the back, which should be there. Go into my 0 where I just took that cut on diameter, which is there, and back out again. Okay, that's that diameter finished. So that said, this top diameter has to be 69 mil. So on my DRO it's 18 mil bigger than 51. So a reading of 9 on my DRO, I set a 0 there. When I come into a reading of 9, we should be pretty much on the right size. So that's, let's have a look, that's 9.5, is it cutting? No. That should cut. It does. That leaves me 10 thou on the diameter. I'll run that cut across and then run the 10 thou, or 0.25. It's a couple of chamfers, so we haven't got any sharp edges. I think something like that on there. Something similar up top here. I think that should do it. And I'm going to get the boring bar out, put a little chamfer in there and a chamfer on the front edge of that. Lathe running in reverse, boring bar over the other side. Little chamfer on that leading edge for the bearing to go in. Let's just see if I can dive inside there. Yes, I can. So I need to put 3 grooves in here. Not very deep, maybe a mil and a half deep, with a little 45-degree angle on either side of them. And I need them equis spaced. So it's 25 mil overall. That's from this space to this space. So 6.25 between them will give me the 4 gaps, 3 grooves. So I've just lined the tool up on the end of the par. I move across 6.25. I'm just going to give myself a witness mark. I'm going to go across to 6.5 and back to 6 mil. And back to 6 mil. That'll take the chatter out and widen the groove. I can go in again. I'm just going to set a 0 on that depth. across to 6.5, back to 6mm. I think just a little deeper. Six mil towards you, to the 6mm mark, away from you, to the 6.5. Just set a 0 there on depth so I know how deep I'm going. Move along to 12.5 now. Okay. So 12.25 and 12.75 is where I'm going to move this time. So that's everything on this side of the part done now. So I need to remove this part. I'll probably put the second one up and machine that to the same level. And then we need to put them in, probably I'll put them in the 4-jaw chuck the other way round and machine the overall thickness here. And a very similar bore in the backside to this one. We've made quite the mountainous swarf. Right, I put the part in, back to front. And it's in a 4-jaw chuck now. I've just eyeballed it in. As you can see, it's running out. I'm picking up on the OD. In fact, let's get somewhere nearer the centre. Where are we? We're probably 0.4, 16 thou out. Okay, find the high point. That jaw there. And the low point, I'll have to lower it off a bit. Okay, back round to the high point. There. Tighten down that jaw, somewhere in the middle. Vast improvement already. High point. Probably about there. The low point is opposite. Loosen up a bit more. There we go. Let's have a look at that. Tighten a touch. A bit high there now, just to nip that jaw back up. Right, where are we now? 0.15, 6 thou. Right, so we're on a different high point. There's the high point. I'm winding these jaws down onto some aluminium, between the aluminium and the workplace. High there. Low opposite, so we'll have to loosen that jaw a touch. Around the other side, tighten that one a touch. Here we are. Getting close now. High here. Now I do need to get this bob on. So I'm not going to bore you until me spending 10 minutes. That one. Well, we're down into 10 microns now. Okay, so we clocked it in on the OD. I hit it back hard against the chuck. So it's, I know it's running true as far as wobble in this sort of plane. And I've also put a clock in the bore here. And that's running true as well. So I've got two different true points that are further or in different distances out from the chuck to each other. They're both reading good. That was a double check, and that tells me that the back face is running true as well. So I can pretty much face off the excess material here and bore it out exactly the same as we did on the other side. So we've faced it to thickness now, 10mm. And put a chamfer on the back. And a little faster, I think. That should do me. And now exactly the same boring procedure of boring it out for the bearing as was on the front into this space. That's it. Just put the chamfers on, the undercut, that's the same on the other side. Happy days, one done. So I enjoyed making that part that much. I made another one. So that's the two of those done, other bar chemical bluing. I am going to have to modify them. I'll show you the drawing here. Can you see it? Yeah, I think it's in shot. Right, the original plan was turn down the piece of bar, and that would be 16mm diameter, and it would be a nice sort of press bit, gentle press bit for the bearings on the 16mm here. This part, the swivel, has to go on first, as you can see in my sketch. Now, if I'd have just press fitted them on and put a circlip groove in to retain it all, it would have been difficult to get apart. You would need pullers and all the rest of it. So the plan B was to have a draw bolt in the end, which was Kris's original idea. So I would make the bar slightly shorter than the combined size of the pulleys with the bearings and all, slightly shorter. And then when you pull it down with a bolt, it'll compress on the bearings and hold everything back, stop it rotating. The only drawback with that is that it would put compression on the inner races of the two bearings, and the bearings wouldn't last very long like that. So I'm going to have to make a spacer, a tube spacer that goes between the two bearings. Inside here, it's only very narrow, so that when it's clamped up with end pressure, it's not trying to collapse the two inner races together. So yeah, that's what we're going to do. We're going to open up the holes in these. I'm going to turn these bars down first to fit. I'm looking for a length of 66.5 mil. 67 is the combined size of these two, this being 32 and these being 35. So yeah, happy days. We'll do it 66.5. That'll leave half a mil for clamping on the end, and we'll make up a nice washer, and we're going to put an M8 bolt, probably drill and tap it in the end, 20 mil long. Then we'll open the holes up in these, make some tube spacers at a clearance on the shaft and exactly the right length, maybe 0.1 bigger than the closed bearings in here, just so that it's clamping on the spacer, not on the pulley, and we're away to go. First of all, I'm going to put this bar in the chuck, and I'm not going to clock it up. I'm going to eyeball it up. I could clock it up, but I'm going to eyeball it up. I've got the chuck somewhere near. Yeah, if I just put a lathe tool in there, come back up by the chuck somewhere. There's plenty of meat to come off this, so we're let's just see. I'm just looking for the gap distance between the lathe tip and the square of the bar. And actually, let me just go around tightening this up. I think we fit it in one. Let's come a bit closer with that tip. I think we're going to call that good. So I'm just going to start it up and have a look at it. And we're stuck out an awful long way, considering we're only holding on about 25 mil in the chuck, which isn't a problem. But I think as I face this end off and put a centre in it and hold it a bit more solidly. I'm just going to tickle this end off, I think. Not going to go mad, or I'll be end up with this bit of bar in my lap. So this black mild steel, as we call it, it's always horrible knotty stuff. It's very soft, easy to machine, but it's sort of draggy and clumpy. Probably the best way to get a finish on this stuff would be high-speed steel, but it'll do all right with this carbide. So we shall center drill it and bring you back. So first pass across the top, we're going to take it down to a diameter of 16. So finishing cut now, and this should bring it down to 16 mil, or just slightly under. So that's the diameter finished. Just drill and tap a hole in the end now, M8. I'll drill a hole about 22, 23 mil deep, and then tap it out with a bottom and tap it in afterwards. So I thought I'd put the parts back in the chuck. In a 3-jaw, I'm holding it with the internally on the bearing race on the back, and I'm just going to bore these centres out to 20.5 mil clearance on the bush. I've got a piece of bar up. I've just drilled an 8.1 hole through the middle. It's just over 20 mil, and I'm making some washers to go under the bolts on the front, nice thick beefy ones for the clamping bolt. So yeah, it's an M8 bolt, so I've drilled an 8.1 hole through the middle there, just a bit of clearance. We'll have a chamfer on the leading edge, something like that, and then we're up with a parting tool. A bit of swarf in my tool post. I'll just line the parting tool up on the edge there, just set a 0, and I want it 3.5mm thick. Here we go. Lock carriage, slow it down a touch, not that slow, and we'll part it off. I'm just going to stop short there. I'll set a 0 again so I know where I am. I'm just going to put a chamfer on the underside of that washer before I chop it right off. So in with the chamfering tool. There we go. Back in with the parting tool. Back to my reading there, and we'll finish it off. And there we have it. So I'm drilling out these spaces with a 16mm drill bit. I pre-drilled it with an 8. So I'm just going to drill them through, or drill the material through, clearance on the 16 shaft. For the 16 drill, typically we'll drill over size. So I've just parted the first one off. I'm just going to skim this. I've worked it out, I want about 11.1mm thick, or overall thickness of this spacer. I'm parting them off 11.5, and then I'm going to turn them round in the chuck afterwards. Some little chamfer on there. Just deburr the whole inside. Okay, so I'll set the parting tool up. Very quick operation this. I got a DRO, so 11.5 on the DRO. I'll just set the edge of the tip. There, on the edge of the job, set a 0. Move back 11.5, which is there, near enough. Let's just load my brush up with a bit of cutting compound, or cutting oil I should say. Part the second one off. Okay, so that's 2 spacers. I just need to machine them now, put them back in the chuck. I would if they weren't that hot. Put them back in the chuck and face them to the set length of 11.1mm. So I've just measured this one up, having taken a skim pass across it to clean it up, and there's 0.25 to come off. Okay, I'll just pick that datum up again. There, set a 0, and we'll just face 0.25 off there. Well, they've been in there for 15 minutes now. Don't appear to have taken that well on this occasion, but it'll have some protection. May give them a quick wire wooling and give them another session in there. Right, so that's chemical blued or blackened. Well, there we are. That's the shaft complete with the bearing spacers and the washers and the bolts all tapped ready to roll. And of course, the chemical bluing, although it's black, the chemical blacking on the two guide rollers. So that's the job complete. So as I mentioned at the beginning, guys, this is part of a collaboration between myself and another YouTuber, which is Kris Harbour Natural Building. So go and check him out, guys. And if you're visitors from Kris's subscribers coming over to take a look to see how these have been made, a big warm welcome to you. I believe that both videos, Kris's and my own, where Kris will be fitting these, and this video will be coming out pretty much at the same time on the same date. So anyway, a big warm welcome to anybody who's come across from Kris's channel. And a big thank you to Kris for giving me this opportunity to help out, basically. It's been a nice, enjoyable project. So, as usual, guys, thank you so much for watching. Thanks for subscribing. Give me a thumbs up if you liked it. And we shall see you all very soon. Cheers now.